Let's consider also this example. We're given the system and we have to write general solution of the system. So the first thing, we have to find eigenvalues of the matrix. If this is matrix A, to find eigenvalues we have to solve the equation when the determinant of this matrix is 0. So this matrix A minus Ri is minus R minus 1, 0, 1 minus R, 0, 0, 0, 1 minus R. And the determinant of this matrix is, multiply this 3, we get R squared 1 minus R. Then this triangle and this triangle will give you 0. This diagonal will give you 0, and this triangle also 0. And only this triangle is left, which is plus 1 minus R. And if we take this 1 minus R out of the brackets, we get this thing into the brackets, and this must be equal to 0. So here we have 3 eigenvalues, and 2 of them are complex. So the first eigenvalue is when this bracket is 0, which is just 1. And 2 other eigenvalues are when this bracket is 0, this is plus minus I. So for real eigenvalue, we already know what to do. We just find eigenvector and write solution corresponding to this eigenvalue and eigenvector. For complex eigenvalues, we just learned in this lecture what to do. So let's do first the real eigenvalue. We have to find eigenvector which will satisfy A minus Ri applied to the vector is 0. So let's write this matrix. So R is 1 now, so this is minus 1, 0, 1 minus 1, 0, 0, 0, 0. And let's say the coordinates of this U will be, let's say this is U1, X1, Y1, Z1. So this must be 0. So this gives us the system minus X1 minus Y1 is 0. X1 minus Y1 is 0. And the third line gives us nothing, so 0 is 0. But we have also Z1, so it means that everything works for arbitrary Z1, so for any Z1. So let's say Z1 to be our parameter S. And what do we have with this X1 and Y1 system? So if we add them, we get that Y1 is 0. If we take difference, we get that X1 is 0. So also we have X1 is Y1 is 0. So U1 now S, and the vector is X1, Y1 as zeros, and Z is S. So this is eigenvector corresponding to R1. And the solution corresponding to this eigenvector will denote X1 of t. This is e to the R1t, so just t, times the eigenvector 0, 0, 1. Let's now find the other two solutions corresponding to R2 and R3. And the first thing that we do, we'll find again the eigenvector. Now the eigenvalue is just I. Applied to the vector. Let's say U2 will be 0. So the matrix I minus I, we can choose minus I, doesn't matter, but in fact, as a matter of fact, it doesn't change anything. 0, 0, 1 minus I. Applied to, let's say, U2 has coordinates x2, y2, and z2. This must be 0. So it means that minus I x1 minus y1 must be 0. And x1 minus I y1 must be 0. And 1 minus I z, this should be 2 everywhere. Z2 must be 0. So from this what we can get that Z2 is 0. And these two in fact are linearly dependent. These are the same. If you multiply by minus I, the second equation, you will get the first equation. So you can write x2 is I y2 and take y2 to be parameter s. So u2 now is x2 is is, z2 is 0 and y2 is s. So let's firstly take s out of this. So this is I1 0, and then let's split the real and imaginary parts. u2 is s times the real part is 0 1 0 vector, and the imaginary part is 1 0 0 vector. So this is our vector A, this is our vector B, and also since R is just I, so alpha is 0 and beta is 1. So therefore x2 of t and x3 of t we will get from this complex vectors. So x2 of t now is e to the alpha t, and alpha is 0, so we don't have alpha t, e to the alpha t here. So we'll get just cosine beta t, and beta t is just, beta is 1, so cosine t times the vector a 0 1 0 plus, sorry, it should be minus sine t times the vector b, which is 1 0 0, and x3 is sine of t times the vector a, and plus cosine of t times the vector b. So let's combine everything that we have. So this one is e of t 0 0 1. So x1 of t is e of t 0 0 1. x2 of t is, so we can combine these two together. So the first vector where the second coordinate is 1, so cosine t, and the second vector, the first coordinate is minus sine t. So x2 will be minus sine t, cosine t, and 0. Cosine t is 0, just to make it shorter. And x3 of t, we can do the same. This will have second coordinate will be sine t, and the first coordinate cosine t. So this one is cosine t, sine t, 0. So the general solution is x of t is c1 times the vector x1. Okay, let's write it, for example, 0 0 e to the t, plus c2 times the vector x2 plus c3 times the vector x3. So this is solution of the given system.